guys, welcome back to my basement. This is 10-6, day 2 word problems. So I'm just going to pick a few word problems to do from the sheet, and then you guys are going to do the rest. You only go up to number 10. All right, so I'm going to start with number 4. So a guy wire is attached to the top of a 75-foot tower and meets the ground at a 65-degree angle. How long is the wire? So basically, these problems are using angles of elevation and angles of depression. So an angle of elevation is when they're looking up, an angle of depression is when they're looking down. An angle of elevation is much easier. I'm going to explain both. So we're starting number 4, and that's an angle of elevation. So always draw yourself a picture. That's the ground. So we have a tower. They said that the tower is 75 feet. So that's 75. And we have a wire that's attached to the top of it. So here you can see your right angle, and they said that meets the ground at a 65-degree angle. So that's right here. So that would be an angle of elevation because it's looking up. They want to know how long is the wire. So that's your X. Always start with SOHCAHTOA. So from this angle, what are they giving us? They're giving us opposite and hypotenuse. Opposite and hypotenuse is sine. So we're doing sine of 65 equals opposite over hypotenuse, 75 over x. Set it up as a proportion, cross multiply, I get sine 65x equals 75. To get x by itself, divide both sides by sine 65. On your calculator, you're going to do 75 divided by, hit second, PRB, make sure sine is highlighted, put 65, close the equal sign, the parentheses, and we get 82.8 when we round it. Is it feet? Yes. Okay. Number 7. A man stands at the top of a 105-foot lighthouse and sees a boat. Okay, so draw your picture. So we need a lighthouse. Here's the lighthouse. Here's our boat. And we have a man standing at the top for whatever reason. Okay, so man stands at the top of a 105-foot lighthouse. So that's 105. The angle of depression to the side of the boat is 37 degrees. So he's at the top, he's looking at the boat. So he looks down at the boat, and the angle of depression is 37 degrees. It is not here, it's up here. So we need to draw a right triangle up here. So this is where the 37 degrees is. If it's angle of depression, it's always looking down. So here is where your right angle is. If this is 105, then this is 105 over here. So to see the right triangle better, there it is. So from here, this 37, what did they give us? Oh, what are they asking for? They're asking for, find the distance between the base of the lighthouse and the boat. So this measurement here. The base of the lighthouse and the boat is this measurement. So from this angle, we have opposite and adjacent. Opposite and adjacent is tangent. So tangent of 37 equals 105. That's our opposite. This is our adjacent over x. Make it a proportion, cross multiply. We get tangent 37x equals 105. Divide by tan 37. And on your calculator, you're going to do 105 divided by tan 37. And when you round it to the nearest tenth, it's going to be 139.3 meters. Feet. And one more. How about number 6? So on number 6, we have a kite that's flying at an angle of elevation of about 40 degrees. So always draw your picture. Here's a kite, and a kite is flying at an angle of elevation of 40 degrees. So draw your right triangle. There's the right triangle. This is your angle of elevation, and they said that it's 40 degrees. All 80 meters of string have been let out. Ignoring the sag in the string, find the height of the kite. So this is 80 meters, and this is your height. So from here, here's your right triangle. From here, we have opposite and we have hypotenuse. So opposite and hypotenuse is again sine. So sine of 40 degrees equals x over 80. Make it a proportion, cross multiply, we get x equals sine of 40 times 80. Put that whole thing into your calculator. Round it to the nearest tenth, and we get x equals 51.4 feet. That's it.